Hello everyone, today we will be solving 9618 Summer 25 Paper 4-1's question number 3. So this is a question about object-oriented programming. A similar question also came in Summer 24's, I think Paper 4-2. So if you want to check that video out as well, you can go to our channel and check that out, because that is a similar question, and this topic, especially when combined, binary tree in itself is a very difficult topic. So when it gets combined with OOP, it becomes a little more tricky to solve. Okay, let's get started. So a program stores data in a binary tree that is designed using object-oriented programming. All right. The tree stores data in ascending numerical order. For example, they've given this tree as an example. So we always start the traversal over here, considering that it's an ascending numerical order. It would start from the bottom left node. So it would go from 1 to then its parent node 20, and then back to its right node. Then it goes up again to its parent node 30, and then it would come down to its left node 33, then 45 parent node, and then 63, which is how it becomes a ascending numerical order. All right, so now the class node stores data about the nodes. So node data is an integer variable. Left node and right nodes are node objects. So they're using a class inside a class, which is something that doesn't come that often in our exam. So this can be a little tricky, but you will get to it soon. All right, so it stores the node's integer data. The node data is going to basically just store the data like these numbers, and then left node and right node would store the node that is stored to the left of the current node, or a null value if there is no node to the left. So the left node or right node would either store the node itself, which is supposed to be on the left or the right, or a null value. So usually when we're talking about binary trees, or even in OOP, we usually have the index of the node in the left or right pointers or nodes, right? But over here we will have the node itself inside the left node and the right node variable inside the class. All right, so it either stores the node to the left of the current node, or it stores the null value if it's empty, right? And it stores the right node to the right, or it stores the null value for the right node. All right, we'll get to these methods in a while. It's just the constructor and then the get and set method. So the get and set methods basically give away that the variables inside of the class are going to be private. So the attributes of the class are supposed to be private. If you see, if it's not even mentioned in the exam, like in the question ahead, it might not be mentioned if the question specifically asks for the attributes to be private or not. But when you see any get or set methods in your class, that automatically gives it away that it's supposed to be a private attribute. All right. So in the A part, it says write program code to declare the class node and its constructor. Do not declare any other methods. Okay, so first we're going to write the constructor. It says initializes node data to its parameter value. So this is the one parameter that we're going to take, and it initializes left node and right node to a null value, which can be any null value. All right. So we're going to start off. It says we're going to start off with making our class like this. Then under double underscore initialize self. Then since there's only one parameter, which is the node data, so we're just going to write one parameter over here. We can call it anything. All right. Then we have the first parameter, which is node data, and we have to make it private. So this double underscore indicates that it's a private attribute. Is equal to node data is going to be assigned its parameter value, and then left and right nodes are going to be assigned null value. So you can make it num, or you can have it -1 or anything, and it just as long as it's a null value. All right. Okay. Now these were easy scoring marks. Then it says write program code for the 3 get methods. So you have 3 get methods over here: get left, get right, and get data, and all of them return the associated attribute, right? So we get the get left, which would return the left node. Then we will do get right, which returns the right node, and then we do the get data, which would return the node data. All right. So we're done with the get methods. Now we're going to do the third part. So it says the method set left takes an object of type node as a parameter. The method stores the parameter in the attribute left node. So it's basically just going to take a node as a parameter and then store that node inside the left node attribute, right? And the same goes for the set right. So the method set right takes an object of type node as a parameter. The method stores the parameter in the attribute right node. Write program code for set left and set right. So first we're going to write set left, and we have to take a parameter value. We can call it new node, for example, and then we are going to set the left node with the parameter value, and then we do the set right, which is going to set the right node to its parameter value. All right, so okay, we're done with the third part. Then we come to the B part. Write main program to declare 5 objects of type node. Node 1 with data 10, 2 with 20. Okay, so we have 5 node objects and of type node basically, right? And we have to declare them in the main program. So now we're going to come outside the class and we can write a comment which is going to differentiate that this is the main program. And then we have to create node objects. Okay, so we can call the first one node 1 maybe, right? And then it's an object of type node, so we're going to write node, which would indicate that we're referring to this class node, and it gives us an option for a parameter which we have to write the data. So the first data was 10, 25, 15, 7. So node 2 is 20, then node 3 is 5, node 4 is 15, node 5 is 7, I think. Yes. Okay. So up till here, maybe ahead as well. Okay. So the class trees, now we are done with the class node. Okay. So we have also created 5 objects of type node, and we're done with all of the get and set methods and the constructor. So we are done with our class node. All right. Now we come to the class tree. So the class tree stores the tree. So that was storing each of the nodes inside the tree, like nodes specifically, and now we're going to store the entire tree in this class. Okay. So tree only has one attribute, which is first node, and it's an object of type node as well. All right. So it's this class is going to refer to the node class as well. All right. So it has an object of type node. So it stores the root node in the tree. And it has 3 methods: the constructor, the get root node, which is going to return the node in the first node, and then insert, which is going to store its parameter node in the correct position in the tree. So this is where the actual binary tree code will actually start. Alright, so the first part says write program code to declare the class tree and its constructor. Do not declare any other methods. So the constructor says that it initializes the first node to its parameter value. So we're going to take a parameter for the first node in the class, and then we're going to initialize it to first node. Alright, so we have our tree, class tree, and then double underscore initialize, and then we have the first node parameter, right? And then we're going to create a node called first node and assign it the parameter value. So there's no other attribute in this tree, so we're just going to move forward because the constructor only has one parameter. All right, now it says write program code for get root node. So get root node returns the node stored in first node. So we're just going to write get root node, and it's going to return self dot double underscore first node. Okay. Now we get to the question. So all of these marks up till now, if as long as you can follow the question and the pattern of the question and you have a basic understanding of what OOP is, these were easy scoring marks. Now we actually get to the actual question. Okay, so it says the method insert takes a node as a parameter and then searches the tree to find the position to insert the new node. Alright, so it takes a node as a parameter and then you have to search through the tree to find the position to insert the new node. So you have to check whether the node's data is less than or greater than the root node's data. So the comparison in binary tree always starts from the root. So for example, we are over here, for instance, imagine, let's say we have to enter 21, right? 21 is the new data that we're supposed to enter. So whenever we start the comparison to find the position of the new node, we always start our comparison from the root node. So this 30 in this case is our root node. So we will start our comparison from 30 and we will check if whether the new node, which is in this case 21, if that is lesser than or greater than the root node. So 21 is, since it's lesser than, it would come on the left side. But since the left node of the root node is not empty, there's already something over here which is 20, then the next comparison is going to take place with this node, which is now going to be 20. So then it's going to check whether 21 is greater than 20 or lesser than 20. So since 21 is greater than 20, and considering that we have to store 21, this node would have been empty, the right node, and then 21 would be stored in the right node of the parent node, which stores 20. So this is how you start your comparison with the root, and you follow through the following nodes, and then you come down to the correct position of your new node, right? Okay. Moving to the left node if the data is less than the root node's data, yes, because obviously you move to the left if the data is lesser, and moving to the right node if the data is greater than or equal to the root node's data. So if the data is either greater than or equal to the root node's data, if you're storing two same values, it's going to move to the right, and then repeating until the final position of the node is found and stores the node in that position. So this question might be a little tricky for some students because here we're dealing with the node itself instead of index positions. So in the left or right nodes, there's not going to be an index position which is referring to a node. It is going to be the node itself, all right? But as long as you follow the information that is given in the question, you're going to get the correct code. All right, so let's start. So this is a method inside the class tree. So first we're going to write the name, def insert, and it has one parameter which we can call it the new node, right? Okay, so we have to check whether the node's data is less than or greater than the root node's data, right? Okay, so for this, to be able to find the correct position and to indicate to the program that the position is found or not, I'm going to create a Boolean variable which I'm going to assign the value of false. So I'm going to make this true when the correct position is found. Okay, you'll see the use for this as I go through the question. All right. So our comparison always starts with the root node. So I'm going to create a variable which is going to store the current node, and when the code starts, the comparison starts, it's going to be assigned the value of the first node, because as I said, the comparison always starts with the root node over here. So we will write this code keeping in mind that I want to enter the value 21. As when you keep a sample answer in front of you, it makes it easier to write the code. And then you can write your code according to that sample value, and then you can generalize it later on. So let's assume that we want to enter the value 21. Okay, so our comparison is going to start from the root node. So the current node that we're comparing our new node with is the root node, regardless of what value you're entering. So the current node in the start of your comparison is always going to be the root node. Okay, then we're going to write the loop, which is going to run until we find the position of the variable. So while found is equal to false, sorry. So while found is equal to false, while we have not found the position of the new node, we're going to keep searching for the new position. All right, so now we get to the comparison part over here. So it says that check whether the node's data is less than or greater than the root node's data. If it's less than, we move to the left of the root node. So we're going to check that if the new node, since it's a object of type node, it has all of these get and set methods. All right. So when we want to access the data from the new node, we're going to use the get data function. Since all of these new nodes and current nodes and first nodes, all of these are objects of the type of the class node, right? So we are going to write if get node dot data is less than current node dot data. That means you move to the left. All right. So considering that we were entering 21, right? So when it comes to the left side, first it has to check whether the left node is empty or not, right? For if we were entering 20, and it would have checked if the left node of 30, which is the root node, is empty or not, then it would have inputted 20 over there, or would have fixed the position of 20. So the first thing that comes after you decide whether you're moving to the left or right is checking whether the left node or the right node is empty or not. So in this case, we're supposed to check whether the left node of 30 is empty or not. If it's empty, we're going to just that means we found the position and the number goes there. If not, then that node becomes our new current node. All right. So in this case, first we have to check that if the current node's left node in the left, if that is equal to the null value that we set in the start. All right. So if it's empty, it's going to be -1. Okay. So if that is equal to -1, we are going to change our current node to we are going to change our current node to the so if it's -1, we are going to change we are going to set the left node of that parent node to the new node. In the case, for example, we were entering 20, the left node was empty, right? So when it was -1, it means it was empty. Then we can store the new node over there. So if it's empty, I'm going to go to current node. I'm going to go to the method set left, and I'm going to enter the new node over there. So this means I found the position of our new node, and I'm going to make found become equal to true. Now, if this left node was not -1, if there was something over there, for example, in the case I was entering 21, there was something over here on the left side of 30, right, which is 20. Now this becomes my new current node, and now my comparison is going to happen with this node. Now it's going to check if 21 is greater than 20 or if it's less than 20, and then it's going to fit it to either the right node or the left node of this new current node. Okay. Now I come over here and I would make the current node become the left node of my previous node. So what this does is that now my current node becomes 20, which is the left node of 30, because this was not empty, this was not -1, so this becomes my new current node. Okay, so this happens as long as the data of the new node is less than the data that was in the root node, right? These are two situations that can occur over here. Either the left node was -1, that means you found the position, you will just put the new node over there. If there was not -1, not a null value, which that means that that left node becomes our new current node, and then a new comparison is going to take place. Now, since found would remain false, the loop is going to repeat. Right now, in the situation that it is greater than or equal to the data of the new node is greater than or equal to the data in the current node or the root node, then we're going to do the same thing but for the right node. So we're going to go to current node, get right, and we're going to check if that is -1. So for example, if I come over here and I'm entering 45, right? So my comparison started from the root node. I checked that 45 was greater than the data of my root node. So I came to the right side. Now I have to check if the right node of 30 is -1 or not. So in the case I was entering 45, 45 was not there in my binary tree yet, this would have been -1. So if this was -1, my new node would automatically go over there. So I'm going to write if current nodes, oh sorry, I've written that already. If that is equal to -1, you do current node dot set left, and then you set it with the new node's value, right? And you do found is equal to true, which means that it would exit the loop. And if it's not -1, means in the situation, for example, if I was entering 33 or maybe I was entering 63, right? And it had come over here. So if I was entering 63, it would check that it started comparison from 30. It's going to check its right node because 63 is greater than 30. It's going to check its right node, but since 45 is over there, it's not going to save 63 over there. Now it's going to now the current node is going to become 45, and its comparison is going to start with 45, right? So now our current node becomes whatever was in the right node of the root node. Okay, and then the loop is going to repeat. Okay, so only two situations in which the left node or the right node are either -1, only then that means that the position of the new node is found, right? Only then we either set the new node to the left side or to the, sorry, to the right side or to the left side, and we put found is equal to true. When we put found is equal to true, it does not repeat this loop. It would not go on and get another comparison. In the situation where the first thing that we, the first node, left or right node that we encounter is not -1, it would do this instead. It would set the current node to either the root node's right node or the left node, depending on our question. So for example, if we were entering 63, it would check the right node, then 45 becomes our new current node, right? This thing gets executed. So now our current node is 45, and this loop is going to repeat. It would check if found is still equal to false. So since we did not find the position of our new node, found is still equal to false. Now it's going to check all of these conditions again. Now it's going to check if new node, the dot get data, which was 63, that is less than 45. Since that is not less, we come over here. Now it's going to check if the right node of the current node, which is the current node being 45, if that is -1 or not. So in the situation where we still have to input 63, the right node would be -1. So since it's -1, that means we found the position of the new node, and then we would set it over there, and found becomes true, and we exit the loop. Right? So this is how you do insertion in a binary tree. Either output in order outputs the data stored in the binary tree in ascending numerical order. So it's a recursive procedure, which means the function is gonna call itself. And in output in order, okay, so it outputs the data stored in the binary tree in ascending numerical order. So in the method I showed you in the start of the question is how it traverses the binary tree when we want ascending numerical order. So it starts with the left node, then it goes to the parent node, then it goes to the right node. Alright, so this is the order that it starts from. Okay, so the procedure takes a node object as a parameter and then checks if the left node is null. If there is a left node, the function calls itself with the left node. So if the left node is -1, if the left node is not -1, then the function would call itself with the left node, right? Then it outputs the data of the current node. So this is like a step-by-step procedure of how the recursive function is going to look like. Then it checks if the right node is null. If there is a right node, if it is not null, the function calls itself with the right node. So they've basically given the entire blueprint of how the code is going to look like. So if you just follow that, you'll be able to get the correct recursive code. So let's check if it's inside the class. No. So this function is not inside the class, so we are going to write it in over here. All right. So it's called output in order. There is a parameter. Yeah, it takes a node object as a parameter. Okay, so we can just say node. All right. So it says it checks if the left node is null. If there is a left node, the function calls itself with the left node. So basically, if the left node, we will do get left, if that is not equal to a null value, which means it has something in the left node, we would call the function with that left node. So we would say output in order, we're calling it again with the value that is in the left node, right? That's what the question says. Then it says outputs the data of the current node. So next it would print node dot get data. I'm just following the instruction that is given in the question so that you can, even if you do not immediately understand how to solve a recursive question, as long as you stick to the instructions given in the question, you would be good to go. Right, which is why I'm just using whatever is given in the question directly, so that considering that it's an exam situation, you would be able to solve it. All right. The third part, it says checks if the right node is null. If there is a right node, the function calls itself with the right node. Right, so we will check that if the node in the right, we will do get right, if that is not a null value, that means you would call the function again with the right node. All right, that's it. This is the question. So when we do this is how you do the ascending traversal. All right. So it says write program code to extend the main program to create a new object of type tree with the node containing the data 10 as the first node. So now we're creating an object of type tree, and it would create an object. The parameter of that object would be the object of type node, right, which is the data 10, which we created the node 1. So we create an object, we can call it binary tree, okay, and it's an object of type of class tree, of type tree, and it has a parameter first node, which is an object of type node, okay, like this. Now it says insert the nodes with the values 20, 5, 15, and 7, which is all of these nodes 2, 3, 4, 5, and into the tree in the order given. So when we have to insert the nodes, we're going to use the method insert, which is of the class tree. So we are going to write binary tree dot insert, then we give the value of the new node. So we do this with all of our 5 nodes. Node 3, node 5. All right, then call output in order with the tree's root node as a parameter. So then we're going to call the function output in order with the root node, which we're going to get from binary tree dot get root node. We could have also done node 1, but this is also a method that you can use, okay? So if you want to understand recursion in more detail, if you just dry run this code, you would be able to understand how the recursive procedure works. But I would also link another video in which I have explained recursion in more detail so that you can properly understand how the recursive procedure works. But I solved it just using the information given in the question so that you can know how to cater to the question in an exam situation where you have no other resource except for the exam paper, right? Now we're gonna run this code. So it says 5, 7, 10, 15, 20. So this is how it did an ascending numerical traversal. You see, it starts from 5 and it goes till 20. So this is an ascending numerical order. So it did an ascending traversal and then it printed all of those nodes. So it was 5, 7, 10, 15, 20, which is also what is in the marking scheme. All right, so if you guys have any questions regarding this specific question, you can ask in the comments. And please do like and share, like and subscribe and share with your friends as well. Thank you.